Hi, everybody. My name is Zeke Torres, and today's presentation is about Git and the way we can manage our code, our data, specifically as SaaS developers, and especially as we start to have more team involvement with other languages like Python, R. We really need to get inspired from what we're going to learn today about Git. So I would like to thank the SaaS Global Forum team. They've done a great job to help us, SaaS users, really bring together and come together as a community, especially as we deal with items like COVID and not being able to gather in person, as they've transitioned and help us see what we can do with virtual. I'd like to thank my family for putting up with me on how to craft all this stuff together to actually get into a virtual presentation. And then my friends, I've talked to them about different things regarding SaaS, but also the future of user groups, and especially on a forum like SaaS Sensei. But thanks to you, the actual SaaS users that I like to talk and network with, not only at SaaS Global Forum, but at regionals and local user groups as well. Please continue to run SaaS. We need everybody's involvement and input to continue to build our SaaS community. So another team where I'm actually working at as a contractor is NORC, N-O-R-C, and they have a center of excellence where a lot of the topics that we're going to cover today regarding Git, version control, SaaS, Python, and R are things that we're actually developing, testing, and finding best practices. That's a great team to be a part of, and I'm happy to be there contributing to these ideas and these methodologies. So I want to thank them for supporting me in not only my user group activities, but also my technical ability to continue to push what I know and what I share. So the resources that you'll need in order to continue your inspired view of Git will be found in the SaaS paper. And so you can continue to look for additional links and resources that take you to YouTube Media to support what you're going to try to learn. That is also reflected in the Git repository that will be part of the SaaS Global Forum release of the paper itself. So why get started? Where should we get started? This paper is going to be a little different because it isn't exactly a SaaS topic. It's about the methodology or the reasons a SaaS developer would engage in learning Git. Typically, we have all sorts of reasons to learn about a SaaS product. We have all sorts of reasons to learn about a SaaS package or a SaaS macro. This is about how SaaS has already incorporated Git into its product base because it's beneficial for us as developers to have more control of our code. Whether you're an independent coder working by yourself, whether you're working as part of a team, whether you're a manager who needs to manage someone or a team, Git gives us the chance to protect the team as more people join the code that we're working on to develop our products and solutions. If you're a longtime SaaS developer who's curious about what to learn next, as you start to hear about Python and R and other languages that encroach our code base, one of the safest places to get started is with Git. Because our teams are already facing more and new members, as well as the ideas that they bring. They bring with them insights about Python and R and how they help projects. That's not going to go away. Git allows us as a team to start to explore and learn about what they're doing. As they work on pieces of their project with the software they prefer, and as we continue to work on the things that we're skilled at, for example, SaaS, Git allows the entire team to benefit from learning about what other parts of the team are doing. So Git is, to me, a time machine. It allows us to start storing our code and going backwards and forwards in time. It is a software that sits beneath SaaS because, again, SaaS has adopted it. It's incorporated into its product base. But it begins to give us a sense of security because it begins to track our changes. So it actually is something you're already familiar with. We are part of the No Problem Club. Often we are told, go ahead and start this project. It's just like last time. Go ahead and do this update to this code because you just need to copy it and do it once. Hey, can I get a copy of the code you worked on? It's just like last time. I'm just going to change something. Or we could have done something last month, last quarter, last year. We could have done something last night with some code of some sort. But now today, we need to put it back. Or we need to put it back to the way it was a year ago. Can we remember what those changes were? Can we actually remember all the places that we touched our code and modified our code? That's kind of a configuration that maybe you could remember if you did it 5 minutes ago. But what if you did it 5 months ago or 5 weeks ago? Or what if you did it to more than one .sas? So that's the kind of stress that we continually have and face in our job. When we have to start digging through folders and finding something, when we have to start digging through not only the code that we're working on, but the logs. I've spent countless of hours looking through SAS logs trying to find a specific log that matched to a .sas that actually matches to the data that was created or that we have or that we wish to have. And then I have to remember, where are the emails that someone sent me to tell me that it was okay for me to make a change or to change it back to something the way it was? So that some code.sas can suddenly become like a detective hunt, trying to find a thing that someone ran at some point in time in some way, and I have to figure out how to change it back. I have to go back in time, and I don't know how. If I don't have Git, if I don't have my time machine, that can be really challenging. So it can get worse, because not only will I need to look at my folders, but sometimes I need to look at team folders or folders of a colleague or a peer that's on my team, or folders of somebody who left the team. Now I have to find not only what I've done to the code, but what they did to the code. And I don't have access to who approved that for them via their email. So you can start to imagine how complicated something simple is that someone told us it's just like last time. How do I put it back? How do I get it back to the way it was? So if at any point in time that happened to you in the last 12 months, if it happened to you in the last 6 months, in the last month or the last week, we need to start talking about safety first, because that is the reason you would want to use Git. So again, we hear that things should be the same, but they're not. Our original copy of our code gets copied into some code.b, which has a little bit of change in it, and that gets further copied into some other code. Suddenly it gets worse. That original copy not only gets copied twice, but as someone else on the team starts to share it, it suddenly begins to spawn out of control. We have so many copies that even if at one point in time someone asked us to reconcile a copy of that code, how do we know which one's the best? So we had code that dealt with sales for the entire company, and somebody wanted an East version versus a West version, but eventually there's all sorts of versions everywhere, and everybody's a little bit different. Which is the right one? So typically in this kind of scenario, we end up hearing that we have the code, we're fine. We can do this, Zeke. This isn't an issue. I know how I code. I know how the rest of my team codes. I don't think I need this, Zeke. It sounds like something that really wouldn't fit into what we're doing. My code has comments. I know exactly what we've done, and I understand exactly what we've changed. It's part of something that I don't think needs to be solved with Git. So we want to start practicing putting the right comments in the right place instead of abusing the idea of commenting our code. Oftentimes we'll see code that has plenty of comments, but they're comments that are meant to be somewhere else. The comments are useful. There's no denying that it's very helpful to understand in this code, in this example, that a manager approved something. But in reality, the comments in our code should be about the things that are happening in the code. The bureaucracy and the approval, the conveying of information regarding the project, which manager or how many rows something had, don't necessarily fit in right next to the code. That needs to be managed in a different place, and Git does that kind of management for us. What we end up seeing is a preference or a style of coding and a tracking of the changes to our code separated out and put in the right place, where we have comments about our code within our code, but then the whys and the facts about the approvals or about the comments of the code or about who approved or sourced facts that go into the code, that is something that Git will handle for us very nicely. In fact, in this image, you're not meant to necessarily see the details of all the lines of code, but you're meant to see how we could even ask for help from ourselves by actually seeing side by side how Git is going to track the changes that we've just made to code before we commit them and move them into a more permanent state, such as like saving the code and the work that we've done. That's really helpful as you want to work on something, make a change, and before you actually commit that or save that into something of more permanence, you can actually verify and see if the changes that you've made are actually what you intended to make. And when you're doing that type of work, you can actually make the comments regarding the changes you intended to make. That's helpful for the next person who could potentially review the code for you. And instead of seeing hundreds of lines of changes in their in that pull request or that effort to help you edit and protect the code, they would only see the changes that you're actually making. So you're in luck. The SAS paper on the Git repo will have the links necessary for you to explore how to get Git installed on your machine, some other tips and tutorials on further explanation about Git and GitHub Desktop, but as well as give you the chance to actually download it, install it on your laptop, and make sure you can start to practice with your code. The next slides are going to cover what we want to do and accomplish with our own SAS code. And that to me was the difference with this presentation. It wasn't just to tell you about Git, it's about how to tell you how we would get started and what some of the best practices are for our own code so we can start to evaluate how we would use Git ourselves. So with our code and with Git, our goal is to protect the code that we're working on from ourselves and also protect it from others who need to work on the code as well to ensure that the code is being updated accurately. But even if we worked on our code 2 years ago or 2 weeks ago, we sometimes need to make sure that we remembered what we did then to ensure the accuracy of what we need to do today. Git allows us to have that kind of time travel perspective regarding the code that we're working on, maintaining, and editing. So change is good. What we're talking about is adapting your workflow, adapting how your team works with code. But you can start with just your own code and evaluate it to see how you would work it into your team environment. What we're going to talk about is how 3 different people or one person with 3 different elements of code would essentially work and edit and benefit from using Git. So one of the elements that we need to work on is standardizing places where we keep our code. Now, oftentimes we have rules as a team where we're supposed to put things in the same place or in a consistent place. That may not always happen. That type of difference, that type of preference begins to cause issues if we don't have a way to track where or how a team or a project has laid out things that are necessary for the success of that project. There could be no organization. There could be differences of folder names, differences of file names. All of those differences and all of those elements of variety can cause teams to really struggle when a project is meant to be the same as last time, but suddenly it isn't because the people who are working on it have changed and are no longer following the same standards. So we have a bigger problem when we have 2 different teams supporting very similar code. Suddenly the preferences of one team versus another team can really cause issues or disruptions. Git is that tool that helps us get through that type of issue. One of the preferred layouts that I have that I've found as a SAS developer really works nicely, especially as other teams begin to evaluate Python or begin to evaluate SQL or R in a bigger team project, is laid out like this. At some point, we're going to have a main folder, which can have many projects, project A, B, C, or D. One of the recommendations that I have is that we have a code folder. That'll be the folder that ideally will hold our Git repository. The folders at the same level like logs, output, and data would be symbolic links and shortcuts. One of the recommendations I have, which is a consistent recommendation about Git in general, is that we don't want to put data inside of a Git repository. As you start to explore more of the learning resources about Git, you'll see that same methodology reinforced. And so one of the places that we actually benefit from this type of layout or folder construction is we're going to have a folder just for our SAS code. We're going to have a folder for Python, we're going to have a folder for R, and a folder for, let's say, SQL. But ideally, we also have a folder for something that's universal. So what would universal hold? What contents would be inside of a universal folder? It could be a .txt file with, let's say, a list of states. It could be a .csv file with, let's say, a list of department names. But it is meant to be code or elements of code that not only SAS can use with a %include, but Python or R can actually reach in and use as well. That universal folder is meant to have more and more elements be decoupled from its original syntax and located or migrated into the universal folder so that other software, other syntax can actually benefit from that process. So what we're missing is the documentation. In that same element of design for that folder structure, we can incorporate a document folder. At that point, Git can accommodate things like Word documents, Excels, PDFs, even images. All those can be stored within a Git repository to supplement the documentation and the comprehensive progress that a project is making as various developers or even managers begin to increase what information they're storing in the Git repository. So let's expand that a little bit more. If I am the developer and I am working on code, I would have downloaded or cloned a repository from a team location and begun to work on my code, obviously it's the SAS one, within the SAS folder. And I would have configured with my IT team a model or preference on how to get the right symlinks or shortcuts to the data and where I would put my logs so that the rest of the team can benefit from that. So that was me working on my SAS code. The benefits now are that in concurrence or at the same time, somebody could be working on the Python code or the portion of Python code that needs to be updated, modified, created for the same project. At the same time, somebody can be working on the code that belongs with R. What we've just described is basically Git workflow regarding a team environment. That means that we are now not only going to code for ourselves and seek other people to help us review what we've done, but they could be working on something at the same time. And that improves our ability to deliver projects on a timely basis. It reduces the complexity and it manages some of the issue of people working at the same time in the same folder for the same project. So a GitHub workflow or a Git workflow involves creating a branch, which is a copy, and we're going to talk about that in a second, of some code. You're going to commit something, save it, make the changes, and make the comments regarding what you've done. You'll open a pull request. It's basically asking someone to check something for you, to verify something for you, to protect the team. And when they do that, they will actually comment that it's all good or that something needs some clarification or maybe that there's an issue and you need to resolve it. But once all that gets done, that gets finished and actually approved and made as part of the permanent repository and code base that the team has and shares. So a pull request process basically consists of a few steps that we do already by ourselves, only now we have the chance of actually documenting it. If you look through this and follow that same methodology of making a change, asking for somebody to review it, commenting or making the updates if they had any questions or issues, and then putting them into production, that's essentially what we already do as developers today. So let's go back to the idea that we've had an original copy of something, then it gets turned into yet another copy. We're using the item or the word copy, but we're now going to start to use the idea that we're going to create branches. Branches allow us to manage those changes without the complication of losing the context of what the changes are about. So in this scenario, we have our original same code.sas, but if we want to do our work, we don't need to rename it to same code b.sas. We can continue on a branch, check our work, make our edits, have somebody else review them for us, and then continue on after it gets merged back to the master branch. Our colleague can be working on the same code, finish their edits, and then merge it back into the master branch. The advantage is that we have the ability to comment and keep the context of those changes all along the way, including looking at our colleagues' code to see what context or what changes they've made in order to avoid a conflict or an issue because we're going to merge those codes together. So, one way to think about it is that there could be different versions of code that our team can be working on at any given time. Sometimes it's even just by ourselves. I could have code for the East Coast or the West Coast or the entire country. And there could be different points of time that I prefer to have that code. It goes back to the idea that we had many copies floating around and I couldn't reconcile which ones they were. Let's expand that example further. The same sumcode.sas is really for an East Coast department or a West Coast department, and at any given time, all of those versions are actually accurate and needed. The difference is that sometimes a manager wants me to run the version from 2019 versus the one from today, 2021. I need to go back and forth in time, and Git allows me to do that. If a manager comes from the West Coast and wants to see the numbers configured, conformed, or adjusted to their parameters, I can switch branches. And if the entire report needs to be about the entire company across the country, I can just use the code in the master branch or the main branch. But if I'm doing my work to evaluate some changes, to make some modifications that I'm not exactly sure if the East Coast or the West Coast is going to want them because they really apply to the main entire company report for the entire department sales, then I'll work on my own branch and eventually I'll make a pull request from the rest of the team so they can review it and approve it so it can eventually get merged back into Git. Those are just some of the ways that Git really helps us start to work better, not just by ourselves, but as a team. And so I really encourage you to get started with Git for some of the SAS code that you have, because that's really a way that everybody is starting to share their code between their peers and their team. I'm really excited to see some of the code that you have on your own Git repository, so please send me links to that. Thank you very much. I appreciate you joining and participating, and I encourage you to write your own papers, your own topics, and share them with SAS Global Forum. Thanks.